.txt. It doesn't allow me to save .r files. So what you want to do from this point is just go to the course and go here to this one, the R code file for plots.
Yeah.
Download that. It will be called .txt. Now, so that would be this file .txt here.
Yeah. Okay.
So the way you rename is you go to rename and then just remove the .txt and use .r, and then go ahead and right click and open this file with our Studio app, RgraphicsBioinformatics.r. Okay. So basically we're on this RgraphicsBioinformaticsLecture.r file, which you can download from here, the R code for plots, which is on the course website. Over here I've also added some supplementary material like this graphics cookbook. Again, feel free to go through this book, and as you go further into detail in graphics. Honestly, this is more for if you decide to do high-end graphics and kind of go into it, but it definitely talks about all the variables and the options, so scatter plots, distribution plots, axis, x-axis, everything there is to know about legends and facets and colors and plots. And again, this is a really detailed 385-page book just on graphics. So it just gives you a sense of how much there is in graphics. So let's just go to the go further down, and as you go here, like you could just look at this. It's such a pretty plot, but you can make all these plots in R. That's what I find it's amazing, is that you can do so many things. Like this circular plot like this, It's such a nice plot that you could just, it's just simple, calling functions, and it gives you the code for all these, so, you can kind of use these code in this book and create all these plots, depending on what your needs are. It's just an example of scatter plots and how to do these. Creating, like boxes like these and highlighting stuff on the side. All of these options are available. Like I said, unfortunately, we can't go into all of this. Like, it's very hard. We could just have a course just on graphics, and then we can cover 6 lectures on graphics, after doing another course in R beforehand, because you need to understand functions and all those things. But the basics now. You know about what functions are, what they take parameters, they take arguments. So for any sort of advanced stuff, all you have to do is now look at the arguments, what they are, understand those arguments, and go from there. And you can pretty much go through this book with the knowledge that you have at this point. All right. So this book is also uploaded, and then there's another book I will be this is actually just the presentation that I used, but this essentially has the same things. But yeah, if I find other stuff, I will upload as well. Okay, so let's go here and right. So this data file, I guess I need to upload it now. Workspace MGH bioinformatics weight data.txt. Got it. So let me quickly, I forgot to upload this file. I will do that now. And in the meantime, you go through the code and see if you can kind of follow what's going on, and I will quickly upload this data file for you. Right, this is just a small file, actually, so it'll take a quick second. Okay, it's done. So go to, just refresh your page where you are. So on your page, just you should be seeing now a new under. Do you see it? Yeah. So yeah, so go there and just download that file. And wherever you save it, that would be your, I would say just save it in your working directory. Whichever directory you want to download the data from, just save it there. I'm going to change my directory as well because so the first thing you want to do is just see what your directory is. So if you do a get WD, it'll tell you where you are, right? So I am in this directory in bioinformatics Rgraphics lecture. Now one option is that I can just take this file and copy it there, and I'll be good. So I can then just go here and just say read.table weight data.txt. Alright, that's the simplest thing to do. Did you see what happened? Just download the file in your working directory, and ideally your working directory should be your graphics lecture folder or whatever bioinformatics folder that you're working in on your local directory. Okay? Alright?
So when I do get WD, I get the function brackets internal get WD.
No, with the quotes.
With the quotes, okay.
With the brackets.
Yeah.
Not the quotes, brackets.
So Michelle, how do I change my working directory again?
Yes, so get WD is to seed the directory, set WD is the way function to change the directory. In that, as it says here, set WD directory, you can go slash, you can just do dot slash, so wherever you are, if you know where, if it's a subdirectory of that, so you can go dot slash, or if you just want to do the absolute path, then it'll be users slash, in my case, I'm guessing it's topper, and then whatever directory you want. So let's say it's in my case I have everything under workspace, and under workspace I have MGH, and under that I have bioinformatics second course. Under that I have my function our graphics lecture. So that's my directory.
Michelle, is there a way just to go to the destination directory and then just copy that address?
Yes, there is. So you can do that in shell. You can open a terminal, and well, I mean technically it's still going to be
I still gotta go all the way through.
you gotta go, or you can go in Finder and get info.
Oh yeah, that's what that's.
So get info, and then over here you can see. Is there a way to copy this directly? No, right?
If you right click on it in Finder.
Yeah, but the get info
So
thing.
you can just go to that folder, right? You just put in set the user, my name, and then desktop.
Go to
And
services.
it's around there.
So you just have it. If you right click and go to services.
Got it. So you go to services.
Desktop folder, you go to desktop.
And then there should be. Maybe I specifically installed a copy path file name.
How do you do that? So it's under options maybe?
Yeah, I don't remember. I did it a while ago.
Show view options.
I think you have
Show
to
library folder.
I think you have to go in and add almost like adding a hotkey.
Yeah.
I don't remember.
So right now, the other files in your downloads folder? Oh, they're both.
Yeah, I think the simplest way would be to, kind of just copy this like this if you really wanted to, and then just go here, and I don't even know if it'll work, but let's try. Oh yeah, okay, so it works. Here. So this is what you do. You go to Finder, you see where your destination, if you've just copied it there, just right click and go get info. And then this path, you just select it like this and just do copy that, Control C, right? This path right here under Get Info, and then you can just open in RStudio. Instead of writing the whole thing down, you can just go Control V. That's it. So this will display that. Does that make sense? Is everybody there? Have you loaded the file?
How do you load it again? It's read dot.
So you do
Set.
read.table. After you've set your working directory, read.table file name with a separator is equal to /t, meaning the tab is a separator, and the header equal to 2, meaning that this file contains header information. That means that there are column names in this text file. Right? So one thing that you can do is, once you've read the data set, one thing you can do is also do a head data set, and that gives you some options about what you just read in. So if you did not do set equal to header equal to true, you did header equal to false, then here's what happened. It does not give you an error. What will happen is that it will assume that the first line in your file is actually a line as part of your data. Does that make sense? Okay. Okay, so now you can do a summary of your data set, and there are only 6 observations here, so it's a small, tells you your minimum, your first quartile, which is essentially
we have to add stuff for it. We have to tell what your so it doesn't really.
Where's the original file? Did you upload it to? Is it
yeah, it's on the folder.
Did you just upload it onto the website?
Yeah.
Okay.
So if you press refresh, you'll have it.
Okay.
Basically, if you wanted to get like correlation coefficients from these guys, you could be like, oh, which of these 3 things? I don't know how you would. I don't know what the syntax would be.
It's funny. I tried getting this data set with table for a while, and I got an error. Unexpected input.
Maybe is it like
Right. So basically, a quartile is the median minus the
because you're still changing this is how it works.
4n plus 1 data points. So the lower quartile is the 25% of the n data plus 75% of the n plus 1 data.
Oh,
Right.
yeah, and it's. I think the standard deviation is 1 if it's normal.
And then
Normally distributed, right?
Yes, standard
Yeah.
deviation would be if you were to calculate it if it was normally distributed. Yes, but I don't think it has anything to do with the standard deviation.
Right. Yeah. No.
Quartiles are separate from the standard deviation, as Wikipedia tells us.
And you know it's always right.
Yeah. So notice we only have 6 data points in the interest of just having a smaller data set. So if you plot it, in my case it'll say the margins are too large, just because it can't see anything here, so I gotta make it bigger. Okay, so let's plot the data set's dollar height, and I don't have the 60,000 observations, so we're just doing the 6 ones that we have, the few ones that we have. So you get that. You can sort it, and then it becomes a much better version after sorting. You can see the parameters for the plot function, but it's just doing question mark plot, and it tells you everything you need to know about all the functions and the type. So we were talking earlier, P is for points, L is for lines. If you want both, what is the main sub, X label, Y label, everything is right here, including some examples. So if you wanted to just use these examples, these are also possible to plot. So here, just as an example, let's plot this. Let's plot the cars data set, and it gives you the distance and the speed for that, and then you can do the plot a line in between here in the plot. Okay, this is from the cars data set. This is not in your file. I'm just saying that it's possible to do it. Everything you see in the examples part of your help, if you do a question mark plot, you'll have the parameters, but you also have a help and examples in the help, right? So go through these examples as well. They're really useful to help you understand what the stuff up and the top is saying. All right? Okay. Okay. So moving on, you can basically plot it with your labels, and you can plot the with different points. So here you're saying that you want to plot the data set hip circumference with the waist circumference, and also notice we say the color is blue and the point is 2. So the PCH is 2 character, which is a triangle, as we said. So essentially it's the same thing. Now we plot 2 by 2 with saying that, you know, minus the 5, 4, 5, 6. So if you just go head data set, you can see that 4, 5, and 6 are these columns, the hip, BP, and the systolic and diastolic. So you don't want that. You only want the height, weight, and waist plotted. So you go minus 4, 5, 6. All right. So you're saying remove 4, 5, 6 columns and plot the rest like this. Supposing I do not do that, what do you think happens? Let's find out. There you go. Everything is plotted with one another. Okay? I mean, it's a little scrunched up here because of my, you know, margins, but you get the picture. Alright, so correlation between waist and height circumference. So you can write the code in it. Go ahead and do it now. Okay. 0.94. Granted, it's a small data point, but anyways. Alright, this is a code. So let's move on. Everybody with me so far? Yeah?
What is a negative C report?
So that's what I was saying. The minus C is to remove the 4, 5, and 6 column in the data frame, in the data set. I'm saying I don't want C 4, 5, 6. Just you know, C is just saying create a vector, right? And 4, 5, 6 are the columns, the numbers in that vector. So essentially, it says that, you know, here in this data set, remove 4, 5, 6, the columns. Okay. So this is the code for the correlation. In case you didn't get it, which is just, you know, just give me x and y with 2 vectors, weight and waist. This is the histogram function. It says question mark hist, which is just saying give me help on the histogram function. It goes here, displays all the options, including, what do we have here? You know, you have the same things. So some things are same. You have the main label, limit, x-axis, y-axis. So these are default for all graphic functions. The label, you know, you just need to remember them once, you know. So all graphics function will take the main label, the x limit, the x label, the y label, all of those are there. The specific things are basically what it takes as the first few parameters, including the x, which is, you know, a vector of values for which the histogram is desired, and then the breaks, which is one of the following: a vector giving the breakpoints of the histogram cells, a function to compute the vector. In the end, it needs a vector with the breakpoints, right? So it could be a function or whatever. The output of that needs to be a vector with the breakpoints if you want the breaks to be appearing. Okay, does that make sense? Okay. So let's go here. Plot a histogram. Nice big histogram with the defaults of 20 on each side. With the color light blue, we created our label. Feel free to, you know, play around, change the color to, I don't know, dark blue if there is any dark blue. Apparently there is. So, and then the label as systolic. You can change the label if you like. And then now let's plot the histogram with the breakpoints as calculated by this. An interesting way to do this would be to just select this first and see what happens. So sequence 80, 120, by equal 2. So if you just select this and do a command enter. So over here, see, this is the vector that is created. Okay? That's an interesting way to go about doing things. Just select this sequence and then see what happens. So that way you know essentially what you're passing as an argument, right? So whenever you're confused, just do that. Break it down into smaller things, run that code and see what happens. And it gives you a better sense of what's happening here. So now, as you can see, it kind of creates those breaks for you. And for whatever data points there are, it creates the bars and gives you the corresponding stuff. Okay, so moving on to box plot. Again, by default, you can create the box plot like this, or if you want, you can also do a box plot and do a help on it. It tells you all the box plot formula, data set, subset, if you want whatever range, width. There's a lot of these options that you have for all the graphics functions. Another thing you can do is do go through the examples and see what box plot does. There's quite a few examples here, so you can do that. Now you do a box plot but with the rug. So right now we just did a box plot, and then now you want to do a rug function, so it plots all these little ticks on the side. Okay, the tick markers appear for the data points, just to show you. Alright, so I'll pause here for people to catch up if they're not already there. You can run everything to this point and tell me if you're there. You're there? Okay. This is simple stuff. I mean, essentially there's not much to it. I'm sure you're probably already finished. Again, this is just help on all of these things. You can go through the help and it tells you, for example, the last one, mtext, tells you what this is. And then this is creating your sequence of sine and cosine and doing the plot first. So let's do the plot. The first one is just the plot in the color green. Type is L and the width is 3. So it's saying the width of the line is 3. Let's see what happens if the width is 30. Right? Just change the parameter to 30. Whoa. Okay? That's how my son would draw. If he would draw a sign, although it wouldn't be a perfect sign, I do not expect him. That's probably an A right there. Okay, so let's change the width back to 3. So notice every time you run the plot, it refreshes this thing, this console. Okay, which is why this happened. But on the other hand, if you do a line, it draws on top of it. So if I do a line 10 and then draw a line like this happens, right? Now, let's say I want to draw another sign, replot the sign with the different things. So all I got to do is just go, again, I could use the lines one, and instead of X, I could do Y, and then instead of green, I could do another color, say dark blue. Okay? So it'll draw on top of that previous line. Alright? We're good? Okay. And finally, the mtext command adds the text over here. Now, going over the side, if you change the side to 1 instead of 3, it'll put this over here. Okay? And it'll override on top of your stuff. So you got to make sure your axis is either labeled or you specify the distance from the mtext. So let's say so then if you specify a line equal to 4, so that's the distance from the line as we were predicting. Is everybody still with me?
So I have a question.
Yes.
So, it plots on top of the other line. Now, if you want to get rid of it and start fresh,
You just do plot. Everything's gone, just the line is plotted.
Oh, so you have to go back up to plot. And
Yes.
do that again. And so that erases the bottom.
That refreshes your
That
console.
refreshes the
Can you only see one plot at a time?
If you go by just plot, you could do just one plot. But lines will always plot on a previous plot.
I'm just saying if you wanted to look at two side by side.
Yes, so that the whole point of that was the par. We'll come to that in a second. The par function. If you do mf row equals to C1, 2. Let's do that. And then do a plot. So that's 1. And then you do a lines. It'll do on this. Another lines. It'll do on this. And the mtext, again, it's still going here. Okay?
But it's only got that one plot display.
Right,
Add another
right.
plot.
Now if you want to add another plot, let's say you want to change the color to red. So now the next plot is plotted here.
Oh, you could go through twice.
Because we said we want 1 row and 2 columns, right? And if row is 1, 2, 1 row, 2 columns, meaning the next plot will be plotted here. Now let's again do the plot. Let's change the color to blue. And now this one is erased again. See? Right, so you start from fresh. Again, the next time you do plot, it'll be plotted on the right side. The question now is, if you do lines, will it go here or here? Where will it plot the red line?
The one on the right.
Exactly. So the new line will be on the new plot because that's the latest plot. The first plot is finished. Okay?
As far as it's concerned.
As far as this concerned, it's
Can you
finished.
specify the location?
I think it'll be within a plot. So you have to do everything for the first plot first, and then you plot the second plot, and then as long as you've done that, you're good.
Okay.
Okay.
I mean, an easier way of doing that for the par thing that you did is just to basically write the whole text for both graphs.
Yeah.
And then that way it'll just go through it once and produce both graphs and that's
Exactly. Exactly. Okay, so let's make some fun polygons. X is this. So what is X? It's a series of 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 8, 7, 6, 5, 4, 3, 2, 1. And Y is this, which is another set of numbers with these coordinates. And then now you'd say you're specifying OP as the parameter, saying MF colon is 3 colon 1. And now we execute the for loop. And we see what it does. Actually, in the interest of time, I'm going to let you guys go through this last step on your own. Essentially, this is a for loop for, in false, true, and NA, and then you're just plotting stuff. Okay, yeah, my margins are too wide. Let's go again. Margins too large. Okay, so this will work with you. It's not working with me because I need to kind of go over that again. Here, okay. All right, you guys see it? I mean, for my screen, I need my margins to be bigger for it to show. But essentially, this is the graphs, the polygons that you're doing. As it's a part of the for loop with these parameters. You're going with the X and Y polygons that you're creating with X and Y vectors that you've done, and you're doing that in the for loop. Okay. The par function is outlined here for you to see what the parameters are for the par. And then the rest is just histograms and other stuff. So multiple plots, we kind of covered that already. This is using the expression thing that we were talking about earlier. So if you have a function and an expression and you just want to print that, it gives you the option to do that. Here. So let's go further up. Right, so this is your text, and now this is the actual expression. Y is equal to 1 to X. I kind of got overwritten because of my margins, but it shouldn't be the case in your plot. It should appear fine. Okay. And the reason why this is like this is because can anybody tell me why? Because the parameter has been set to 1, 3. Right, so before I draw this, I'm just going to change my par, and then it'll run fine. Okay, now it's back to being the usual self. And then finally, this fits very nicely here. It's no longer divided the way it was. All right. So you can do this just plotting other stuff. And then this is the redirection part where I was saying, you have X and Y as these two vectors. And then if I want to create a plot like this, it plots it here. But now I'm creating a mygraph.pdf. Are you with me? I'm redirecting the output to the PDF. Okay. And then now, if I do the plot, you would only notice it if this was empty.
To show the camera.
Yeah. Right. So I'll do a dev.close. Oh. So, okay. I guess try the dev.close on your file and see what happens. Do you get the same error?
Yes.
Do you guys want to know why?
Could not find function delta.
Yeah.
Do you want to know why? Anybody? Take a guess.
Do we set up a PDF?
Well, that's because dev.close does not exist. The function that exists is dev.off. All right, so you do that, and then you do dev.off, and then it says RStudio GD. And now let's go back to our directory, and voila, we have our graph right here, the PDF file. Double click on that, it's like any other PDF file, regular stuff, you know. So it's a good way to redirect your output. All right, cool stuff. Everybody get their PDF? All right, so let's move on to the next part of which is essentially the heat map part, which is, you know, this is Ben's stuff. So download Ben's heat map file from the zip file here. This is important stuff. So download it here and save it, or just go right click and save it to your actual, you know, file folder, wherever you want to save it to. This would be bioinformatics or bioinformatics, whatever folder you are in bioinformatics. And then go ahead, save it, and then go to that folder and double click on it, and you should get this BSW cluster with this date folder in there. Are you getting this?
Yes.
Okay, so now there are two parts to this. There's the documentation, which Ben talked about, including terminology. I would click on the terminology first and go over it briefly. So these are the column names at the top, and this is called a column dendrogram if you're not familiar. Main is the main is the actual label. What do you know? Computer scientists have a sense of humor too. So, so this is a column phenotype, which is basically, you know, the other stuff that you've labeled here. This is a row dendrogram, which is on your row for your rows. Row names left is called this. This is the row phenotype right here. This, and then this is the heat map ramp here. This is his essentially the terminology. Now, first things first, let's go over to the packages section. Okay, so there you'll find all these tar.gz files. Don't unzip them. Let them be. All right. Now, if you go back to the presentation and open Ben's presentation, if you're not already there, and you will see over there he talks about here installing the packages. Now, the way he's created this, you have to install the packages in this order, okay, in order for it to work. We went over how to install packages. Just I'm sure most of you have forgotten, so we'll go over it quickly once more. So
Not quickly.
not
Slowly.
slowly. Okay.
I can't watch and read at the
Okay,
same time.
got it.
I think your definition of slowly is very different.
Okay, all right. All right. I'll slow down. So, so everybody in our studio.
Yep.
Cool. Step one done. All right, next step. We want to go under tools. All right. Everybody in tools. Install packages. Okay. So you have multiple options when you're installing packages, and this drop down tells you what those options are. You can go to the CRAN repository, the CRAN universe. This is the R universe, which has these open source packages where Ben is saying that essentially, eventually, he's going to deposit his code and package on this universe, and then everyone on the planet has access to this stuff. For now, you can there are other packages which we might want to download from the universe, but the second option is this: package archive tgz or tar.gz file. This is what we're going to do right now. Now, if you click there, it automatically takes you to the location where you installed from. In our case, we will go to the directory where you have your files, the zip files unzipped. In my case, it is my MGH bioinformatics directory. In your case, it'll be wherever you have downloaded and unzipped that file. Under BSW heat, you go to this 26.4 file. Under packages, now you're ready to select one of these packages you want to install. So the order for that, we go back to the presentation, is this order. So we're going to start with UDI package. Okay, so go here and start with the UDI, which is probably, if it's by date modified, it'll be 1, 2, 3, 4, 5th package. Here, select the UDI package and click open. You're still on this window. Good. Are you with me? Okay, now click install. If you don't get this red thing that says done, that means we need to install some dependencies or something else. Does everybody get done? Perfect. Now let's look at the next package in this list. It's util, right? In the list right here. Util. So we're going to go same thing again. Tools, install packages, browse, and it should by default come here. Let's select util, which is this package. Okay, util. BSW util underscore something. Click open. Install. Okay, it should be doing some compiling. If it gives you something else, it's probably because of some dependencies.
So I got a warning.
Got away with a warning. Okay.
The make command requires the command line developer tools. Would you like to install the tools now?
Say yes.
Install. Your computer isn't connected to a power source, so great.
Ah,
Okay, so this is the thing with installations, you know, it'll tell you stuff.
It's not installing either.
It's not using it.
Oh man, yeah, you have a special installation.
Don't
Yeah.
worry about that right now.
Okay, yeah, that's the best thing to do. You know, go back and if it means that there are certain dependencies that you need from Ben, we'll get you
Yeah.
set up with those things. All right. In the meantime, for those of you who were able to install util without any warnings or any other thing, you may proceed to the next package, which is the BSW plot. Try that, and then it'll give you same thing: tools, install packages, browse, and BSW plot. Now I have installed the dependencies, so mine might install. For you, it will or may ask you to install some other packages like bswarm, VCD, color space. Now, whichever packages, does anybody get that?
Yeah.
Okay, so which package did you get?
bswarm.
Okay.
Color space.
Okay, so perfect. So there you go and click on install packages. Now, instead of saying the tar.gz, go to the repository cran. Okay? That's where you install from your universe. And you search for BEE. And as soon as you type BEE, it auto-completes and gives you bswarm, right? Just select that and say install and click on install dependencies at all times. Make sure this is checked, the install dependencies box. Okay, install. So it's just going to go ahead and connect to the repository and then install it. Do the same thing for all other packages. So the next one was what? Color space? VCD. Go select VCD and click install. Notice there's another way to do installation in R. You just do install.packages. So here I'll do this one like this. Install.packages. And then in quotes, I will select the package name, which is color space, right? Is the S capital? Marcus, is the S capital?
No, it's not.
Okay. So I can also install just like this. We're just doing on the command line, type install.packages and in quotes the name of the package I install. And it does that for me as well. It's the same thing as going through the other route. Okay? They both do the same thing. All right. Now after this, again go back to install packages. After you've installed the dependencies, select the package tar.gz. Are you there with me? And then select the BSW. What's the package name? Plot.
So it worked, it said a warning, these files are built under R version 3.25.
Yeah, as long as you got a warning, you're good. I mean, it's just giving you a little warning, but yeah, you can ignore warnings sometimes.
But it says done, right? It says it.
Yeah.
So what do you do if it
Do
doesn't
you
say
have to do
done?
this each time?
No, this is a one-time thing. Let me specify that.
Oh, I did the plot.
Once you're done with this, we can get to the good stuff. So let's do this.
So then you have to save the file that you did it in, or the
No, it just means that you have to do it in this R environment where you installed everything.
So the R is changed from one page to open up the new console.
Oh,
Yes, if you change the
it's only blank. I need to see that.
yeah, if you start again, I mean basically as long as you're in the same R, meaning the same R computer,
Yeah.
it'll store everything and you don't have to do it again.
So mine's not able to find the software, so you want me to just come
Yeah, just do it later. Keep your life simple for now. Alright? Okay. So we'll do the next step, which is to install the BSW plot after installing the dependencies. Alright? Is everybody, well, almost everybody with me? Okay. So after installing plot, what's the next thing that we need to install? This is BSW grid. So select grid, again open, install, and okay, yeah, I get the same warning, so no worries. You can ignore that warning. Install packages. The next package we want to install is BSW wcore. So install the browse BSW wcore. Open, install. So, okay. Next, tools, install packages. And BSW class 10. Alright? Class 10, the top, this one. Open and install. Okay. Tools, install packages, the final one. BSW heat. Open. The last one. Install. Now we're done. Okay? Is almost everybody done? So congratulations, you've just installed Ben's package on your computer. I mean, so that's a good start. So now, the next thing we want to do is go into the examples, which is under doc, right? So you can open that, and we can start with BSW clust examples, which is this, which talks about clust and file, and essentially, or BSW heat examples, and I think we're going to start with the BSW heat maps. I like that more. Okay, so one is about clustering, and it tells you, alright, so let's start with the first one. It doesn't matter. You can start with either. So open that in your RStudio. Okay. Open that file on RStudio, and we read through Ben's comment as we continue to go through this, and you know, alright. So first thing we do is do the library BSW class 10. Okay? Alright? So yay! Didn't give any errors, just warnings. So now the next thing we're doing is creating a matrix with 21,800 rows and 15 columns and some column and row clusters. Okay, so just setting a random seed, creating an RPM matrix, alright, and assigning it some values. If you're really interested, you could do a head on RPM to see what it looks like. So this is your matrix. I mean, I have very little space here, therefore it's spanning across 2 columns, but you have sample 1 to sample 45. All right, this is your matrix. And if you place it like this, it's probably going to look better. Just do a head on RPM. Okay, so 45 samples, and if you do a dim, it'll tell you how many rows and columns. 21,800 cross 45 matrix, and you've populated them with random values. This is something similar to what you'll get in your gene count matrix. Okay, that's what we're trying to get at here. Okay, so the first thing you want to do is, compute the clustering. He says we choose the top 2,000 rows with respect to the RPM matrix, and then the clustering of those rows is done using the log 10 of the RPM plus 1 count. So whenever you calculate log of something, you just add a 1 to it in case, because log of 1 is 0, so whatever your 0 values were will become 0 again, and it won't give you infinity. That's why you do a plus 1. So you're adding 1 to the entire matrix and then calculating a log 10 of that. Right? And then you're calling the .clus function with the top number of rows to use for clustering, and there, that's basically it. Now this is a part where you plot it to PDF. You're creating an example PDF over here. Again, I'm going to see which directory I'm in. I'm still in my graphics directory. Let's pass it the clust, and that's it. And so let's see what it created here. This would be here. So my example 01. So this is my first clustering of the entire data set of the 25,000 rows. This is what it looks like. All right. Pretty much all your samples are clustered based on what the distance is. These are your values. That's what it looks like. This is a starting point to go further down. Now, so basically you add a few more things, tell what units are being used for the main heat map. So now, this was the first one. Now example 2, our thing is just saying this is the difference, is like you're saying median polish log 10 RPM versus nothing. Okay, here you don't have the label, you added a label. All right, yeah. So this way, I think if you keep going further, you can just add column phenotype data. Again, it's a data frame with gender, male, female, with other stuff, including what is their hometown, Chicago, New York, Chicago, LA, temperature. So if you want to look at that, you can always do this. It's a 45 row data set because it's describing the columns. So there are 45 columns. It tells you what each one is. And the reason why you need a data frame for this is because you have multiple options that you want to display over there. This makes more sense when you display it with the plot to file in example 3, and you specify the column phenotype here as your description about the actual column data. So now when you plot it, this is where it starts to become interesting, because now you have all these 3 gender, hometown, temperature rows basically describing each of your samples and color coded in this particular way, saying that which of those samples are male, which of them are female, which of them are from Chicago, LA, or New York City, and all of this data was added because you were able to specify this data right here in this column phenotype, right? So this is essentially what it is. A lot of times you will just have probably one column in that, saying that certain samples are from tumor samples, and certain samples are your normal samples. In which case, you just create one. Basically, your data frame will be one vector, right? And that's fine. But it'll still be very useful to have this kind of information on top, displayed on top for each of those samples, right? Does that make some sense? Okay. So I think basically I'm going to end the lecture here, but essentially, if you go through this example file and finish, running each of these, you should be able to, plot really nice heat maps with this. If you have specific, I'd like it if you use it for your specific case studies that you're doing in assignment to use this package for your heat maps. But yeah, it's really just very simply describing what your rows are, what your columns are, and feeding them those data frames here, and you get these really nice heat maps. Okay, all right. If you have any questions, redirect them to me. I can go over whatever your requirements are and help you through these packages. Okay, but it's no more complicated than just basically designing your vector of what describes your samples. So this sample is of this type. Supposing you have, you want to do multiple labels, right? So that was our example here, right? It's multiple labels. We're saying some of the samples are tumor, some of the samples are normal. That's one class. And the second type could be some of these samples are, I don't know, positive for some gene, and some of them are negative for some gene. All right? So you just label those two as two columns of description in your data frame. Okay? Do you have any questions so far? No?
You just gotta do it.
Yeah, you just have to do it. Essentially, that's the bottom line. Okay? All right. So we'll end the lecture here. For next time, the homework I would suggest is to go through these examples as well as the ones in plot function, and absolutely come let me know what problems you have. Now for this Thursday, before you leave, this Thursday, very important. Dr. Ting will be giving a lecture this Thursday. All right? So please do try to make it from 2 to 4. All right? Oh. Okay. So we'll record the lecture and we'll put it online. Unfortunately, he cannot do Mondays, so he'll be doing the lecture on Thursday. Who all will not be able to make it apart from you? Everybody else? You can't make it either? Okay. So, but everybody else can? Yeah? Okay. All right. Well, like I said, we'll record the video, and when I record the videos, I'll make sure it's, very nicely done. So, all right. So let's stop here.
Michelle, are we going to have a lecture on GSEA?
Yes. So our remaining lectures include Dr. Things on Thursday, next Monday DE-Seek, and I'll try to do ChIP-Seek as well in the lecture. And then in that week in the practical, we'll do both practicals, DE-Seek and ChIP-Seek on Thursday. And then after that, we do gene set enrichment analysis as one of the last lectures in May. And then one lecture in June would be there, because that would be the lecture where you guys present. Or if not, I'll do some lecture on whatever else is remaining. All right? So we have about 3 lectures remaining, 3 or 4.
Thanks.
Right.
Is it 2 p.m. right on Thursday?
Huh?
2 p.m. Thursday?
Yes, absolutely.